Hello everyone! Today I'm here to talk to you a little bit about algae-based biodiesel. So let's dive right in! Well, the 5% of the vehicles on the road that use diesel fuel account for 23% of all transportation emissions. That's astounding! So that's why we use biodiesel fuel. But biodiesel fuel is great right now. We use feedstocks like soybeans and corn oil and canola oil to make biodiesel fuel, which is then burned in diesel engines. And across this cycle of growing the feedstock and finally burning it, it reduces emissions by 77% compared to diesel fuel. That's great. But most of the oil right now is produced using soybean oil. And there's a big drawback, and that's that it uses vast amounts of arable land. And that's a problem because it competes with the agricultural sector, which is why we need another feedstock. Enter microalgae, or algae for short. Now, algae has a few great benefits. First of all, it is 150 times higher in productivity than first-generation soybean oils or second-generation animal fats. And further, or more importantly, it does not require any arable land. And it still has the same benefits of reducing greenhouse gas emissions. Now, there's a problem with algae as well, though. Not everything can be perfect. And the biggest problem is that it is too expensive. Right now, it is twice the cost of diesel. And if it's not cost effective, many people won't be able to use it. And that's what I focused on. First, I try to minimize the cost of biodiesel fuel. Previous studies have attempted to look at algal biodiesel. However, they have a common flaw where they don't incorporate all of the most cost-effective processes into one big process. So that's what I tried to do, to minimize cost. And second, I tried to minimize the pollution of producing this fuel, because a fuel meant to minimize emissions shouldn't have emissions during its production. And lastly, I tried to exceed the minimum quality for use in the United States as defined by the American Society for Testing and Materials. So my methods involved using a process simulator, which is this big blob right here. Super complicated, or at least it looks like that. But it's really simple, actually. It's just a graphic user interface that incorporates a bunch of mathematical equations that helps me simulate growing algae, harvesting the algae, then extracting the fats from the algae, and then converting this oil into biodiesel fuel. So basically everything can be simulated in a computer. And here's what I found. I was able to reduce the cost of algal biodiesel to 10% lower than diesel fuel. Now this is unheard of. If you go to gas stations down the road, you'll see that biodiesel is almost always more expensive than diesel fuel. Quite a bit, as you can see here. However, I actually made a fuel that's cheaper. That's great. And that's exactly what we need right now. It's cost effective, satisfying my first goal. But let's take a look at the second goal. Well, by using this closed loop hexane extraction highlighted right here, I was able to recycle all of this harmful chemical almost every time, 99.9%. That reduces emissions by 99% compared to previous studies. That's great, satisfies my second goal. And lastly, let's look at the quality. Here you can see that the CQ biodiesel exceeds the red zone and is below the red zone here. So that means it exceeds the minimum ASTM standard for quality in the United States. So that's great. To conclude, this means that I made a fuel that is cost effective, has low pollution, and exceeds the minimum quality, all while not requiring any arable land. This means that all the trucks you see on the road that are transporting your food or your furniture, all your goods, those will be producing 77% less emissions when using my fuel. That's exactly what we need at exactly the right time. Thank you for listening, everyone. Have a great day.